In the previous session, we have discussed about the operations performed on dependent variable, that is amplitude. We have covered amplitude scaling. We have seen some two examples how to do the scaling. Then we have seen the addition, how the addition or even the subtraction is performed. We have seen with the help of two examples. Let me take one more example just to clarify how the addition occurs. In continuous time, two examples we have seen. Now let us see one more example in discrete time. Okay, this is the problem wherein x1 is given in this manner, some amplitude values, see 0, 1, 2, 3, 4, they are having amplitudes 2 and 1. Then at -1 also 2. This is first signal, this is your second signal. Horizontal indicates time, as it is discrete time, take small n. These are the vertical, indicating the vertical line as signal x1 and x2. Till this, okay, draw x1 and x2 one below the other. Then I think I have done multiplication here. No, addition only. I think I have lost this. It should be plus, okay, x1 plus x2. Now let us start with the 0 point. At 0, what is the amplitude shown for first signal? You can observe here, the point is here, okay. So amplitude is 2. Now 2, and what is the amplitude for second signal at 0? 0. We don't have any point here. So 2 plus 0 is 2. I have pointed at 2 and straight line. So at 0, the amplitude of the added signal is 2. Then coming to the time 1. At 1, again amplitude is 2. You can see here it is constant. And at 1, amplitude is 1. So 2 plus, whether it is plus or minus. Let me just confirm it because I have done some mistake, I guess. Let's see. Okay, let me take it by addition only. So 2 plus 1, you should get 3. So actually I have done here subtraction. 3 means this should be extended. You just make this correction. This should be 3. This is 2. Then take the time 2. The value is here, it is 2. Here it is also 2. So 2 plus 2, somewhere here it will extend 4. Then amplitude is 2. Again, here it is 3. 2 plus 3, 5. Somewhere here I will point it. You draw it neatly, okay. 5. And at 4, you observe the amplitude is 1. Here no amplitude at 4. So 1 plus 0, you should get at point 4. The amplitude is 1. Then at -1, the amplitude is 2. Here the amplitude is 1. 2 plus 1, you should get 3. Okay, I have made the corrections because whatever I have drawn, the other one, it is for negative, minus. Okay. So amplitude at 0, it is 2. At 1, 3. At 2, 4. At 3, 5. At 4, 1. And at -1, it is 3. So this is how the addition takes place. Similarly, what I have drawn, let me show you. I have done it for negative. Okay. So for negative, let me start with the 0. 2 minus 0 is 2. Then 2 minus 1 is 1. Then 2 minus 2 is 0. You don't have any amplitude. Then 2 minus 3, 2 minus 3 is -1. So at the negative side, -1. Then at 4, you have 1 and here nothing. So again I should change it. At 4, you will get plus 1. Okay. Then at minus 1, it is 2. 2 minus 1, it is 1. This is 1, this is 2, this is 1, this is 0, minus 1 and 1. So this is how the subtraction of two signals occur. If you just compare the continuous and discrete, addition and subtraction, you will feel it bit easier. Okay. So this is about the addition and subtraction this is the operation of addition and subtraction on in a dependent variable amplitude. Okay, let us continue with the next operation, that is multiplication. If you know this addition and subtraction, how to do it, it is similar to that multiplication also. Earlier you used to add or subtract the amplitudes. Here you should multiply the amplitudes. That's the difference. Let x1 and x2 are the two continuous time signals. Then the signal x1 into x2, see here a dot is there in between. It is called the multiplication of these two signals. So how we get this output product? It is obtained by taking the product of those amplitude values. We should take the product. In addition and subtraction, we have added and subtracted. Here in multiplication, we should take the product. This is defined for continuous time. Similarly, we can define it for discrete time. You see it, if there are two signals x1 and x2 of n discrete time, then the signal x1 into x2 multiplication dot, it is called the multiplication of two signals. And how you get this multiplication product? It is obtained by taking the product of those two for all time. Again, in order to understand this multiplication, how it is performed, let's take one or two examples. We'll see how to perform this multiplication. Okay, take the first example. Again, x1 and x2, I have taken the same as that of the previous. Same signals. One range is between minus 1 and plus 1. The other range is between 0 to 2. Okay. Now, draw those two signals one below the other. Exactly times should coincide. Okay. Now, with this, let's start. If you observe the first signal, before this minus 1, there's nothing. So it is 0. Here also no amplitude. So 0 into 0 will not get any amplitude. Now coming after 1. So let us take one time, minus 1 to 0, this range. Amplitude is 1. What is the amplitude here? It is 0. Earlier we had done 1 plus 0 or 1 minus 0 in the addition and subtraction. Here we will do 1 into 0. Hence, nothing. Here the amplitude is 0. Similarly, considering between 0 and 1, that 1 unit of time, amplitude is 1. Here also if you observe, in between these two amplitude is 1. 1 into 1, you will get between 0 to 1, amplitude is 1. Now, after this, if you observe, there is no amplitude at all, 0. However, the second signal, you have the amplitude 1. Earlier we had taken 0 plus 1 and 0 minus 1. Here you should take 0 into 1. So again, between 0 to 2, if you multiply 0 by any value, you will get 0. And furthermore, all 0 into 0. So the signal ends here itself. There is no value here, 0. So only if you observe between 0 and 1, the amplitude exists, because there is a common amplitude here both. Here amplitude is 1 and 0. Here amplitude is 0 and 1. So this is also 0. This is also 0. Here it is 1, 1. Only between 0 to 1, the value exists. Let's take one more example. This was about continuous time multiplication. Now let's see the discrete time. This is one given signal x1 of n. This is x2 of n. Let's see, first you draw both the signals one below the other. Times should coincide. They should be aligned. Now let us start with the 0 point. Amplitude is 1 for the first signal. Here we don't have any amplitude. See, nothing is marked. So amplitude is 0 here. You can mark it here, something like this. Okay. Then at 1, amplitude is 2 here, amplitude is 1 here. 2 into 1, you will get 2. Here amplitude is 1, amplitude is 2. 1 into 2, answer is 2. Now coming to the left hand side, it is minus 1 into plus 1. Minus into plus, you will get minus. 1 is the value. So minus 1. So below negative side, you should get the below line minus 1 amplitude. Then if you take minus 2 and minus 1, what is the multiplication of minus 2 and minus 1? It is minus into minus, you will get plus, plus 2. That's why here it is positive side plus 2. Okay. So I hope you understood both the examples. Here there is one mistake which I have done. If you can observe here, see how I have marked. One I am pointing it as minus 1, the other minus 2. But if you observe the lengths, both are same. It should not be. You should extend this and point it here and write minus 2. That is correct. Okay. So this is how multiplication of two different signals is performed. Coming to the two more operations on amplitude. The first one is differentiation. This you have already seen in case of when we were dealing with the relationship between u of t, r of t and delta of t. There we have seen some example also. So let us define. Let x of t be a continuous time signal. Then how we can define the differentiation? Here the variable is time. Generally, when you deal with calculus, x is a term which you use for differentiation and integration. Dx, dy, dz, something like that. So here the variable is t. Hence, it is given by the output y of t is equal to d by dt of, because variable is time, d by dt of the input signal x of t. This, at least now, as for now, you remember the definition. Okay, when we come across certain problems in case of energy and power signals, you'll understand how the differentiation is performed on signals. Okay. Similarly, the way we defined differentiation, we can also define integration. So if you consider x of t be a continuous time signal, then the integration with respect to time is given by some integration. Range is given as minus infinity to t, or you can even write like this, t1 to t2 in general. Okay, generally, or minus infinity to plus infinity. Some range, over certain range, x of tau d tau. Tau is one variable which we replace by time small t. Okay, just not to get confused. Okay, we make use of the third variable. That's why you can even write like this, another variable, x of m dm. All are good. Tau is just a variable which is used. Okay. So this is about differentiation and integration. The example problems or the examples how to do differentiation and integration, when we deal with the energy and power signals, you'll understand this. Okay. Okay. I hope till now what all we have taken in the today's first and second session regarding the operations performed on amplitude dependent variable, amplitude scaling, addition or subtraction, multiplication, differentiation and integration. I hope these all you have understood thoroughly. I know it is the first time that you are trying to draw the signals and operations. It should have been done in the offline class, but as we don't have any alternative till the college starts, please make sure that whatever examples today I have shown you, just to make you understand regarding addition and multiplication, Those examples, please put it in the notebook. Put that, you try to practice that. Okay? Anywhere if you get difficulty, you can ask me. So in the next session, in the next class, we will start the second type. Let me show you. Yeah. Now today we have discussed all these. In the next session, we will start this. That is operations on independent variable. That is time here. So we now, if this is your signal x of t, till now we were focusing on here, whatever the amplitude part is there. So if you draw a 4-quadrant system, we were focused on this vertical line which is representing the amplitude. But now onwards, when we are now discussing the operations on independent variable, we should focus on this horizontal line, time. Okay, if you observe here, in whatever examples I have shown you, we have not touched this time part. Okay, horizontal, see here what is the range, it remains the same throughout. Whatever operations we have done, horizontal axis are untouched in all the three. Only amplitudes are getting changed. Similarly, let me show you the addition part. Range is -2, -1 to +2. So between this only we got the result. Here the range is again -1 to +2. Between these two only we have got the range. That range remains unchanged. Only vertically the things are getting changed. Multiplication, again range is between -1 and +2. Within that range only you have got the answer. Here it is range -2 to +2. Range is between these two only. Only the vertical part, the amplitude is getting changed till now. But from now onwards, the next session, that is for operations performed on time, independent variable, we will see that the horizontal line that is representing the time, it will affect. Whenever you do some those operations, vertical line gets changed. So let's see that in the next session. If any doubts, please ask me, either unmute and ask me or put it in the chat box. I'll give you some time. Any doubts, please ask, please let me know. Understood, fine. Hopefully everyone understood. Any doubts, please let me know. Ask me, you can ask me personally. Put the question also even in your group or personally, no problem. Okay, thank you so much. We will continue in the next class.